For this construction project, we're going to build an interface to allow your computer to control your transceiver. The term used for this is CAT control, CAT standing for Computer Aided Transceiver, which gives you the capability of changing settings on your transceiver, for example the transmission and reception frequency, the mode such as FM and SSB, and can make logging of contacts much easier. If you change frequency or mode on the transceiver, the computer will also know instantly of the change and update the information displayed on the computer's screen, as well as modifying the information in the logging software.
Hello, I'm joined by Dave, Mike 7 Whiskey Uniform Tango. In the last of these videos, we were working with Jenny M6 JUT, and we built an audio interface so that you could get audio into your radio, from your radio into your computer, and from your computer into the radio. You can also use your computer to control the radio, so change its frequency, see what frequency it's on at the moment, send it in to transmit and back to receive, that sort of thing. That can be really useful if you tie that into your logging software or other applications that you're using with your radio. So Dave, today we're going to build one of these either CAT interfaces or data interfaces that lets our computer talk to the radio and send it different commands.
Excellent.
Different radios do this slightly differently. Some of the more modern ones will actually have a USB socket straight on the radio and you can just plug a USB cable in, but others don't have that and you have to build a special cable. You can buy these ready-made or often build them yourself. You've got, I think, a Yaesu radio?
Yeah, FT818.
Great, so that uses a system called CAT, which is Computer Aided Transceiver. That's Yaesu's name for this system. To build one of these cables, we're going to need a few different bits. We're going to need a plug that plugs into the back of the radio. This is an 8-pin MIDI DIN. A bit of cable, that's 2 cores plus an overall screen. And a USB to serial converter. Now, there's slightly different types of these. There's ones which go to RS232 levels, and there's one which go to what are called TTL levels. That's sort of 0 and 3.3 volts or 0 and 5 volts. So we've got a USB to serial TTL converter. You can buy these on a lot of online shops for a couple of pounds. So hopefully you've got all of those in front of you.
Yep, looking at them right now.
Great. And I'm also looking at the manual for the radio. This is on the page, it says cloning, but it's actually got the sort of the pin connections that we need for this lead. So on that MIDI DIN, as we look at the back of the radio, we're going to need to make 3 connections. We're going to need to connect a ground, which will connect to the shield of the cable. Transmit data, that's data coming out of the radio when it sends information to the computer. And receive data, which is when we're sending information from the computer to the radio. So we'll connect those two to the 2 sort of main conductors in the cable and ground to the screen. Cool. So you just want to strip maybe about 1 inch of the outer jacket off with some wire strippers or a knife. And on this wire that we're using, it's got a sort of foil screen. You can just get rid of that, tear that off, and there'll be a separate actual screen wire. You might need to just use a knife to help get rid of that, or some cutters. And you can do that at both ends. Now, once you've stripped off a little bit of the insulation, you'll just want to give these wires a quick twist, just to make sure all of the different strands are held nicely together. For the inner wires, you don't need to take off too much of the insulation, just a few millimeters. So once you're ready to start tinning those, you just want to apply a little bit of solder. You don't want any blobs. You just want to apply a little bit of solder to each of those wires, just to hold everything together and to prepare it. Now, what you'll probably want to do is on those inner conductors especially, you probably want to, now that you've tinned it, just shorten it down. You probably only want a couple of millimeters of exposed conductor, so you can just chop those down a little bit. You don't need an awful lot at all. And the more you have, the more likely it is that you'll short together these pins in the DIN plug because they're quite close together. So you now need to take the mini DIN apart, and there's a few components to that. There's the sort of outer sleeve that just pulls off. You'll end up with this sort of two-part plastic case, which again splits apart. Then a sort of two-part metal jacket that comes off as well. And finally, the actual pins themselves. And you see there's one side which will plug into the socket, and the other side has little buckets that the solder is going to go into. Now we're going to want to prepare that in the same way as we did the wires. So we're going to want to tin that. And if you look back at the diagram, we're going to want with this held with the 3 pins at the top. You're going to want to tin the middle row of 3 connectors here. So you're trying not to get any blobs of solder that might cross over between the different pins. You just want to tin those 3. When you're holding these in your helping hands, try and hold it by the plastic, not by the ends of the pins. Otherwise, as it warms up, the pins will tend to squash in the slightly softer plastic, and then they won't line up anymore. So I'm just going to apply a little bit of solder to each of these pins in that middle row, heating up the pin, then applying solder to the bucket. Once you've done that, then you're ready to introduce your cable. So we're going to put the ground wire on the right, and the receive and transmit doesn't matter too much which way around those go at the moment. So now we just need to reassemble that chassis around the plug. Again, this can be a little bit fiddly on these. Start off with the outer shell, and you'll see one part of this has a sort of a single hole in it. The other part has a double hole. And the double hole goes over the slightly wider spaced pair of blobs on the connector. And a single hole on the other side. Great, so once you've got that silver shell on, then it's the solid plastic bits. Those go on at sort of 90 degrees to the first ones. Again, lining everything up with the little blobs.
Cool, that's going to go nicely. Yes.
And then the last bit is that outer jacket. Now, hopefully you haven't soldered anything onto the other end of the cable yet.
Nope.
Always a good idea to put that outer shell on before you start doing the soldering the connector, but I forgot to in this case, but thankfully I can pop it on from the other end of the cable.
Is it worth checking now that nothing's shorting?
Yep, that's a great idea. So if you've got a multimeter, you can just check between each of those pairs of conductors, and none of them should have continuity. You can also check between each of those bare conductors and the pin at the other end. Remember, if you're looking at the connector from the front this time, they're going to be the opposite way round. So your ground pin, as you look at it from the pins, is going to be on the left. And your receive and transmit data are going to be in the middle and on the right.
So I take it we're now attaching this.
We are. You've now got your USB to serial converter. And if you have a look on the bottom of that, you will find some labels.
Oh yeah, TXT, RSC and ground.
So yeah, we've got on here 3 volts, 5 volts, transmit, receive, and ground. We don't need to worry about the 3.3 and 5 volt pins for this. Just going to need the other ones. Now, it is important that we swap those TXD and RXD round compared to the radio, because when the computer's transmitting, the radio's receiving. And when the radio's transmitting, the computer's receiving. So here, the receive data, that's the radio receiving data from the computer, we're going to need to connect to the TXD pin. And my blue wire, the radio transmitting data, is going to want to connect to the receive data of the computer. So you're going to swap those two around. Otherwise, the computer will be transmitting into the radio's transmit pin, and that's not what you want. So ground goes to ground, RXD goes to TXD, TXD goes to RXD. Now you can either solder to these connectors directly, or you can get some 0.1-inch jumper wires which sort of plug onto these, and then you can solder onto those. Here we'll just solder straight onto the pins. So again, we're going to tin the pins first. So on my side, the blue transmit is going to go to receive. If you're soldering the ground wire on, by the way, if you have some, you can put a little bit of heat shrink sleeve over there just to keep it away from everything else.
Rob, you can learn to solder from the master. Look at that.
Very good. Great. So that's all of our soldering done. We're now ready to head over to the computer and the radio and see if we can get them talking to each other. Great. On the computer, then, you can first of all plug in that USB to serial converter that we had, and we'll find out whether it's first of all showing up, whether it needs drivers, and what COM port number it's gone on. So if you plug it in, and then we'll go into Device Manager, which on Windows 10 you can do by right-clicking the Start menu and going to Device Manager. At this point, under Ports, COM and LPT, that'll give you a list of all the serial ports that are installed on your computer and which port number they're at. If you're not sure which one the device that you've just plugged in is, the easiest thing is if you just unplug it, see which one of those two devices disappears, and then plug it back in, and it should hopefully reappear.
Yes, we're good.
Great, so that's on COM6. If we now go into the logging software, there's lots of different bits of logging software available. Some is better for contesting, some better for casual operating. For this example, we'll use DXLog, which is freely available, dxlog.net, and that's really designed for contest operation. So it's great for high-speed entry of contacts. If you fire up DXLog and then create a new contest by going to the little wizard icon in the toolbar, it'll ask you to enter some details. So your call sign is the obvious one, but for some contests, you might have to enter something else that you're going to send as an exchange, like your locator square or your DXCC. Just your call sign is fine here. And then we'll select which contest we want to enter. Now, if you just want to have a play around, then the DXpedition setting is a good simple one. That's just going to send and receive call signs and signal reports. It's not going to use serial numbers or anything like that. You're also going to want to change the mode. At the moment, it's CW only, so it'll only allow you to log Morse code contacts. If you change that to mixed, then it'll also accept voice or data contacts as well. Then press OK, and it'll ask you for a file name. Generally, for contest logging, you'd sort of have one file per contest entry, so that you keep all of those contacts separate.
Cool.
Great. This is our basic log. And if you were to just type in a call sign, say you work me, M0VFC, you can type that in and press enter, and that'll go in the log.
Fantastic.
Great. But you might notice that that's currently showing us 160 meters CW. That's just the default band and mode that it's assumed we're on. That doesn't match what the radio is set to at the moment. So to do that, we need to tell DXLog where our radio is and what sort of radio it is. It was on COM6, we remember from Device Manager. So if you go to the Options menu and Configure Interfaces, you can see a selection of COM ports here. Not all of them might exist on your system, but under COM6, which was the one that our COM port was on, if you tick the enabled box and then in the drop down to the right, tell it that this is radio 1. For most cases you just need a single radio, but it will allow some advanced use with 2 radios at the same time. Press the setup button next to that. That's going to allow us to tell DXLog what sort of radio you have and what the communication settings are. So under that radio drop-down, you can select the model of radio. In this case, it's an FT818. And then we need to set the correct comm speed. This is the speed at which it sends commands back and forth to the radio. 4800 baud is correct for the default setting on the 818, but if you have a look in the menus, then you can just confirm that. I think it's called cat speed.
Cat speed, yeah. Yeah, it's 4800. Yeah, it is.
Perfect. So that should just match between the radio and the computer. Most of the rest of these settings, again, you can leave as their defaults. Some radios, some interface cables will need you to set different settings for those DTR and RTS lines down at the bottom, but for the 818, we can just leave all of these. Once that's ready, if you press OK to that dialog box and OK to the one behind it.
Okay. Ooh, a light on my radio flickers.
Now that's good. If you look up in that Radio 1 panel, you can see that's now saying 4301625. Does that match the display on the front of your radio?
It does. I can't believe it worked first time.
Brilliant. So if you now change frequency on your radio, maybe send that down to 10 meters or something like that, using the band up and band down buttons on top. And you can see that the logging software is keeping in sync with the frequency on the radio.
Nice.
So if you take it into one of the HF bands, because by default, DXLog is configured to just allow operation on the HF bands with this sort of contest.
So like 1821, something like that?
Yep, that's perfect. And you can see down in that logging row where we're ready to type the call sign, that now instead of 160 is showing 15 because you're on the 15 meter band. And this works both ways. If you wanted to get the logging software to tell the radio what frequency to go to, if you just type in 20 for 20 meters on the computer and press enter, you can see that the radio has now gone to 14 megahertz.
Nice.
This works for modes as well. So for example, at the moment you're in SSB, but if you were to type CW and press enter, that's now changed the radio into the CW mode. And it's also changed that default signal report to 599 rather than 5 and 9.
It's coming.
Great. This is your basic logging setup. You can also go a little bit further and integrate this with the DX cluster. So the DX cluster is a sort of set of connected stations, nowadays mostly over the internet, where one station can say, hey, I've heard this other station on this frequency. And you can pull that information into your logging software and let you very quickly tune to that frequency.
Okay, so it gives you hints about who might be able to listen to you.
Exactly that. So to do that, if you go to the commands menu and DX cluster, and then connect to the default cluster, it'll ask you for a username and password, but for many clusters, this one included, your username is just your call sign. And you can leave the password blank and just press OK. If you go to the Windows menu, there should be one which is DX cluster monitor.
Okay, cool.
So that you can now see coming into there, there's what we call spots. This is indications that one station, in this case IZ6PPU, has spotted IQ6XX on a frequency of 7057. On that Radio 1 panel, that's showing you a band map. So that's showing you the sort of surrounding frequencies and a list of stations on those frequencies. There's probably not a lot going on 80 meters at this time of day in Europe. But if you go on to, let's say, 20 meters, you now see that there are stations showing up on the band map. Those are coming from the DX cluster. And if you double click on one, you can see it should have tuned your radio automatically to that frequency. Similarly, if you were to tune the main VFO dial on the radio, you'll see that yellow line start to move around on the band map. And in fact, if you tuned it through one of those call signs, it'll highlight as yellow, saying, oh, this is probably who you're listening to on this frequency. It's always worth checking with your ears, making sure that really is the station you're listening to. But it's a good hint. And that's pretty much all there is to connecting your computer to your radio using cat control or serial commands. Different radios connect up in different ways. As well as connecting to logging software, you can also use cat to do things, for example, put your radio into transmit or back to receive in data mode software. So we experimented in one of the other videos with WSJTX. You can use that same cat lead to send the TX and RX commands to your radio. You still have to have the audio cable plugged in as well to send the actual audio tones and receive the audio tones, but it's how you control and command your radio from your computer. Thanks, Dave, and enjoy the new cat interface.
Yeah, it looks like I've got everything I need to now do some serious competitioning.